Okay, so yesterday till where we have done?
Yes.
Till here, okay?
And also this is done. Yes, this is done also. Yeah.
This one?
We stopped here.
Okay.
Yeah. Mm-hmm.
Okay, so supervised learning problems can be grouped into classification and regression problems. So if we have, for example, the output variable, like our target variable will be the discrete one, like categories, maybe cat, dog, yes, no, or for example, ABC in this form, then we will apply the classification. But if our output is continuous, then we will apply the regression algorithm. Okay, so it's like
Yes.
some temperature will be in some number, maybe like 22 point something, 32 point something. Same price will have like from $1 to maybe millions of dollars. So like a lot of continuous values. So then we will apply regression. Otherwise, if some categories like cat, dog, yes or no, email is spam or not, something like this, then we will apply the classification. Okay.
Okay. Okay. Yeah.
So uh, we have some previous record, and from that record we can apply classification or regression. It depends like what is our target variable. If our target requirement is the continuous, then we will apply regression and we will get the percentage score, like maybe 86 point something, 89 point something. But if we have just pass fail, then we can apply the classification and it will be like pass fail. Easy.
Yes. Yeah.
Okay, so here if you can see, it's the launch status, rejected, approved, rejected, approved. So because there are only two like categories, so we will apply the classification. Okay, so if this one is our target variable income, in that case it can be the regression problem. So the majority of practical machine learning use supervised learning. Okay, so the goal is to learn a mapping from input X to output Y, given pairs of input as follows. So we know that these are the independent variable and this Y is the dependent variable, or you can say this X is the input variable and this Y is the output variable. So if we want to know which are the input variable and which are the output variable,
Okay. Yes.
you have to tell me which one is input variable from these three.
The input is age,
Hmm.
and the target is the income.
No.
Right?
This age and income, these both are input variable. Only one will be the output variable. Like what we actually want to do. If our plan is to find the loan status, then this is the target variable or output variable, and all others will be input variable. So this age and income will be X, and Y will only be one variable, which is loan status.
So the loan status is the output, right?
Yes, this is the output. Okay. And age and income is input. Okay.
Yeah.
Great. So the goal is to learn a mapping from input X to output Y, given pairs of inputs as follows. So we have a data set which is from I from 1 to N. Okay, what is N here? N is
it's unlimited.
N is the number of training examples. N is the number of training example. How many training examples are here?
Here, 1, 2, 3, 4, 5, 6, 7.
Great. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 input examples. So N will be 7. Okay. Yes. Yeah. So what is D? D is dimensional space of input. D is the dimensions. What is D here? D.
Dimension, it is the, for example, it's array.
No. D is dimension. Dimension is like this, like column is dimensions. One column, two columns, something like this. And this column is target column. We will not add this column. Okay. The
So it's
final,
two-dimensional.
yeah, only two dimensional. Okay. So if, for example, there is another column here, maybe the person name, then it will be three column. We can say it's three-dimensional data. Okay. So n is the number of training examples. So how many examples? 7 examples. And how many inputs are the dimensions? 2 dimensions. Okay.
Yes, two-dimensional with 7 inputs.
Yes, great. So this xi, yi, it means that if I is 1, then this column is talking about this one, 21, 20,000 and rejected. He is talking about this one. So if I is 2, then 37, 55,000 and approved. Did you understand?
Yes, yes.
How about I equal to 5? If I is 5, then what? Which one he is talking about?
It is 34,
Yes.
7,000.
70,000. Okay. And approved. Great.
Yeah.
Yeah. So if we can just confirm that what is the value of I. So he's talking about I is from 1 to n. It means that he is talking about the whole data set. 1 to n, n is 7. So he's talking about the whole data set. And xi belongs to this one, this part, these two column. And yi belongs to this launch status, this whole column. Okay. And
Yeah.
this,
Yes.
he said this xi belongs to R of D. R of D means real valued inputs
R.
with D.
Yes.
Okay,
2.
so D is dimension. So D is 2.
Yes.
So he's talking about that one input training example is two-dimensional vector. Okay, so it means that 1 and 2 is two-dimensional vector. I depends which value. If I is 3, so maybe this 21, 29 and this one. If I is 5, 34 and this one. If I is 7, this one. I is 6, this. So this
Yes.
is talking about the whole data set. So if you want to show the whole data set in only one equation, then you can show in this way. Easy?
Yeah. Yes, it's easy now.
Okay. Here D is called the training set. So D is the training set. So this whole is the training set. And N is the number of training example. These are training example 7. D is dimensional space of input, like how many dimensions in input. So this is 2 inputs. Xi, yi is example is a pair consisting of an input object. Maybe it can be an image, and a desired output value is label. So this is input can be some values, maybe some image, anything. And output can be the label, like rejected, approved, or maybe cat or whatever. Done?
Done. Yes.
Okay. So the goal is to approximate the mapping function so well that when you have new input data X, that you can predict the output variable Y for that data. So it will give you the new input data. New input data means some test data set, new input data. Okay. And you have to
Yes.
predict the Y. Like I told you, like in the test data set, you have to predict the target class. Like the some label, you have to tell the label, because in the test you have to tell the label. And new input data is the test value. Based on these test input data, you have to predict the Y, the label for that data. Learn to predict new example. So Y equal to f of x is like there will be some function. It can be a function, it can be an image, it can be some values, it can be data, whatever. So you have to predict based on this Why? So for example, he say
Yeah.
they give you this image. Based on this image, you have to make some model, and then you have to predict the label of that. Like apple will be the correct value of correct label. But if it will give
Yeah.
some banana or something, then it will be wrong. Okay.
Okay.
So till here we discussed about supervised learning. Now we are discussing about unsupervised learning. What is unsupervised learning? Did you remember?
Unsupervised, it means unlabeled data.
Great. So
Yeah.
unsupervised learning is where you only have input data and no given desired output y. Like there is no label. You don't have label, but you only have the input data x. So what you have to do, you have to
Mm-hmm.
make this, you find the similarity and you have to make the groups based on the similarity. Because you don't have the y, you don't have the label. So you have to make your label by yourself by finding the similarity. Example, I have photos and want to put them in three groups. For example, these are different photos and you have to make the groups, three groups. So then you can make the red group, blue group, and something like this. So useful for learning structure in the data, like clustering. You clustering or grouping or something like this, you can say. So you have to find the structure and you have to group the data or cluster the data. Hidden correlation. Hidden correlation mean there will be some correlation. Correlation mean like there will be some similarity. They have some relation. So based on that relation, you have to make the groups. And you have to reduce the dimensionality. So there are three things which you can do in unsupervised learning. You can make the groupings based on similarity. You can find the hidden correlation. There will be some relation you can find, or you can reduce the dimensionality. What is the reduced dimensionality? We will discuss it later. For example, here, if for example we have only two inputs. For example, if there are 100 inputs, you can reduce the dimensions maybe 100 to 10 or maybe 100 to 3. So you can reduce the dimensions based on the importance. So how we can do that, this will check later. So did you understand this point?
Yes.
If you have any question, you can ask.
So, doctor, we have actually, I understand what clustering means, grouping the data,
Yes.
and hidden correlation, it's mean similarity, right?
Yes. It's like whatever the relation.
And
It can be similarity, it can be any relation.
similarity, or for example, if I have apple image, banana, strawberry, it's all type of fruits, right?
Yes, there can be some pattern, maybe not
Yeah.
similar, but there can be some pattern. Pattern is like one thing is increasing, the other is decreasing in the same way. Or for example, if one is increasing, the second one is also increasing. So in this way, like we can say, for example, we have two columns in the data, and we want to know that if, for example, if I am learning something, then you are also learning. If I am sleeping at like 9 p.m. and you are also sleeping 9 p.m. So we have some relation. Okay, we have some correlation. So we have to find that
Yeah.
correlation between the data. So whatever the correlation, you can also find that.
Yeah.
And next.
Yeah, next.
So reduced dimensionality, what is this?
You said we will discuss this later. But we,
Naughty girl.
yeah. I can understand reducing the dimensionality just to, actually, I have too many ideas. For example, the cost function and to remove noisy, right?
No. Reduced dimensionality is like, for example, if there are 20 columns, maybe there are only two. But if there are 20 columns, okay, 20 columns, and two columns are not important, then we can remove those columns and we can reduce total dimensions. For example, if there is the name of a person, so based on the name, you cannot reject alone, whatever the name. For example, if there is name is David or Abdullah or whatever, you cannot just reduce the
Yeah.
name. And it means that name is not dependent on this column. Okay, so you can just remove that column because it's not important.
Yeah.
So in
So
that
yeah, so
case,
unimportant columns, by using the reduced dimensionality, we will remove any unimportant
exactly,
columns.
yeah. So
Yeah.
unimportant columns you can remove. So it's called the reduced dimensionality. Okay, second thing is, for example, if one column is talking about the date of birth and second column is talking about the number of days or how old he is. Okay, how old he is. For example, one column is age column and one column is date of birth. So we can remove one column because both are giving the same information. Am I right?
Yeah.
Yeah.
Yes,
So
right.
in that case, you can remove one column because you don't need two columns. So you can reduce the dimensionality by removing one column. If you can get the same information from one column, you can remove the other one. So this can another example of the reduced dimensionality. Okay.
Yeah.
So unsupervised learning, the way is like you have some input data, some images, and then you apply the machine learning algorithm model, and then you group the data, maybe cat, all cats in one group, all dogs in second group, all birds in third group. So something like this. Okay.
It's clear. Yeah.
Okay. So unsupervised learning can be divided into. So these three, he is talking about the same which we have discussed. Clustering. What is clustering? Clustering is grouping. Clustering is a technique for finding similarity groups or similar groups in data. Okay, so called cluster. So we have to
Yes.
make the groups in the data based on the similarity. What is association? It's about like an association rule. Learning problem is where you want to discover rules, you know, a priori.
Yes, I know. I've tried it. Yes.
Yeah, so this is like you can find the association, correlation. You can find the correlation. Like for example, if a person will buy the bread, so he will also buy the jam. So you will find the similarity, the association or correlation. Third one is the dimensionality reduction. It's the from higher features to low features. Like if, for example, we have 100 features, 100 columns, you can remove it to some less column, maybe 10 columns. So clear?
Yes, it's clear.
Okay. Next is semi-supervised learning. Semi-supervised learning is an approach to machine learning that combines a small amount of labeled data with a large amount of unlabeled data. So we have some data is labeled and most of the data is unlabeled. So some data is supervised learning like labeled, some is unsupervised like unlabeled. So we call it semi-supervised learning. Okay. So semi-supervised learning falls between unsupervised learning with no labeled data and supervised learning with only labeled training data. So we have two types of data, unsupervised like unlabeled, supervised learning, labeled data. So if, for example, semi-supervised is the between these two. Some data is labeled, some is unlabeled. So we have here like labeled and unlabeled data together, and we will apply the semi-supervised learning algorithm.
Yeah.
Okay. Next is reinforcement learning. In reinforcement learning, an agent is interacting with the world over time. We teach like we have the We have time based on with the time we are learning. Okay, like agent is learning. As I told you, for example, we teach it good behavior by providing it with rewards. So if, for example, he will do something good, he will take some, agent will take some action. If the action is good, we will reward him and he will learn. If the action is not good, we will punish him, then he will unlearn those things. So he can learn the things, he can learn the good behavior based on the reward. Easy?
Yes, it's easier.
Okay. So what are the applications of reinforcement learning? Its applications are creating agents that play games such as chess or Go. So like chess game, if you want to play or any game, so you can create the agent who will learn how we actually play the chess or how we play some game. So based on that, for example, if he play a good move, he will run a good move. Then we will reward that agent, and he will learn that okay, this is a good move. So if he will do a bad move, then we will punish him. So in this way, the agent will learn about some game. Another example, controlling the cooling system of data centers to use energy more efficiently. So this is another example. And third is like designing new drug compounds. So it's like, for example, the same thing. Like, for example, we are using different drugs, chemicals, and after making two chemicals, we have something new. So if that will be a good chemical, then we will reward. Otherwise, we will say, okay, that's the bad chemical, and he will use different hit and trial method to design different drugs based on the different combining different mixing different chemicals. So this is like making the drugs. We can use it. We can play games, like how to play game. We can make some agent, smart agent, or we can make some agent to cool the system of data centers. So, any question?
No, it's understandable.
So these are some machine learning algorithms which we will learn with the time. Like supervised learning is linear classifier, like linear regression or something like this, or maybe some that kind. And naive Bayes is another algorithm, SVM, sport vector machine, Bayesian tree, random forest, KNN, neural network. So most of these algorithms they added in your content. So maybe they will teach you all. Okay, so with the time we will learn what they are doing. And unsupervised
Okay.
learning, PCA, TSNE, K-means, DB-scan, and reinforcement learning algorithms are like salsa and q-learning. So these are different names of the algorithms which you will learn in this semester. Okay,
Yeah, okay.
any question?
No, it's clear until now.
So AI, machine learning, and deep learning, what is these? AI is the parent of all. Like AI is the main thing, as we discussed. Like what we have to do, it will talk about this. But how we will do this, it's the subset of the AI, machine learning. And what machine learning cannot do, that will be done by deep learning, advanced form of machine learning. Okay, so AI
Yeah.
is about building machines that can sense, reason, act, and adopt. Sense is like, what is sense?
Since, for example, camera, like in a robot,
Good. So like,
actuators, yeah,
yeah. So
and
sense is like,
effectors.
sense is like not actuators, but sense is like, yeah, camera, mic, or
Mm,
something like this, touch. When it touch something,
yeah.
so there is some sense. So based on this sense, he will reason. Reason is like, is it correct or not, or maybe what is this, something like reasoning, and then act
Ah,
accordingly. For example, if he sense that there is camera and he sense that there is a signal, reason is like what signal it is. If it's red, action is stop. If it's green, reason, then it will move. And adopt is like based on the action, all these, he will adopt something. Okay, so this is learning.
Yeah.
ML enables machines to learn from experience, a useful tool for AI. So how actually he will reason? To, for the reasoning, he must have the experience, he must have the training. So based on the reasoning or adoption, he must have the experience. So training is like the machine learning. So this is a subset of the AI. And deep learning focuses on a family of learning algorithms loosely inspired by the brain. It's like neural network. Okay, so neural network, most of the neural network algorithms like CNN, CNN, LSTM, and many other algorithms, which he will not discuss in this
CNN,
semester.
RNN. Yeah.
Yes, true. CNN, RNN, LSTM, and BERT, and like by LSTM, GRU, by GRU, a lot of algorithms in deep learning. All are based on the ANN. Okay, like artificial neural network. Based on that, they have a lot of new algorithms, which is part of deep learning. Easy.
Yeah, it's easy.
Okay. So, can you read this?
Okay, labels and features and samples. Label, when, for example, when we have a data, when we said this data is labeled. For example, dogs, fruits, home, like this.
Great.
Features, it's mean the main characters. For example, this dog has eyes, long, for example, long ears.
Great.
And sample, when we choose a sample from the dataset, right?
Yeah. So actually, these features are the columns. Okay. For example, if we have a table, the target variable will have the labels. Like for example, dog, cat, whatever. Okay. This
Yes.
features is the columns. Like we will have the pixels of a picture, our number of bedroom, number of washrooms, number of floors, number of like these kind of features. Or if, for example, we have a cat picture, as you told, like the the, the ear, the nose, the face of nose, the shape of nose, are like all these things. Number of eyes, number of something like this, whatever. So these will be the features, and this will be written as columns. Okay, for example, if uh, in this case, these are the features. Age is feature, income is feature. Okay, so these are different features, and examples
Yes.
are the these one. 7 examples. Examples mean number of sample data. Okay, so sample is like a example. A sample is a particular instance of data. It could be labeled or unlabeled. So if, for example,
Yes.
there is not this column, the lawn status, then these all samples, 7 samples or 7 examples are unlabeled. But if this is existed, thus we can say that okay, these 7 examples or samples are the labeled. Okay, so it's clear.
Yeah. Yeah, it's clear now.
So definition and so like labeled sample and unlabeled sample. As we discussed that labeled sample are used to train and validate the model. These are usually represented as XY, where X is a vector containing all the features, as we already know, like age and income. And Y is the corresponding label. As in the table, we have the loan status. Remember?
Yes, yes.
Yeah, so for example, a labeled sample could be 3 to 1500, something like this is the some X like input data, and then this is the label. And unlabeled samples contain features, but they don't contain the label. Like we have the X, but we don't have the Y. So we usually use a model to predict the label of unlabeled sample. So we use something like unsupervised learning. Okay. We group the data based on similarity or something like this. So if we have the labeled sample, then we actually apply some supervised learning. If we have unlabeled, then we can apply the unsupervised learning. So label we have supervised, then unlabeled and supervised.
Yes.
And what is training? Training is a process that builds a model. We show the model labeled samples during training and allow the model to gradually learn this relationship between features and the label. So actually what is training? We have to find the relationship between these. For example, what's the relationship between this input features with the this output feature? So we have to find the relationship between these two. This is called training. Okay.
Yeah,
So
yeah.
features like we have the input features are columns and the label is the target variable. So we have to find the input features and the target feature. We have to find the relationship. So training data used for training learning algorithm, often labeled data. Of course, we have labeled data, so we will do the training. So we have the YOFI, and this is the same like we can train. What is validation set? Validation set is a set of examples used to tune the parameter of a classifier. So we have to tune the parameters of a classifier. For example, to choose the number of hidden units in a neural network. Because you didn't learn the neural network, so maybe it will be difficult, but yes, you can just say that whatever the parameters we have, so we have to tune those parameters by using another set, which is validation set. So in this case, we will divide our data set into three parts. Previously, we said we will normally split or divide the data set into training and testing. But if we want to tune the parameters, we also have to make the validation set. And test set, a set of examples used only to assess the performance of a fully specified classifier. So test data we only use to test the learning algorithm. So as we already know that we have a data set, we convert, we divide it into training and testing. Testing data set we use to train the model, a training data set, and the testing data set we use to check the performance, that how much accurately the model has learned. Okay.
Yeah, it's clear.
Okay. So these are 7 steps of machine learning. We have to gather the data. We have to do some pre-processing, like remove some missing values, remove the noise, and remove the outlier, something like this. And we have to normalize the data. These are different techniques to prepare the data. Then we have to choose the model, like we want to apply, supervise, unsupervise, reinforcement, which model we will use. So if supervised, then should we use the regression model or classification model, and which algorithm we need to use. Then we will train, then we will evaluate, then we will have hyperparameter tuning, and then by using testing data set, you can do prediction. So these are 7 steps which we will use. Any question?
Okay. No, doctor, thank you.
Okay. So here they just said that we have different data set repository, and you can just use any website to download some data. Okay, for example, if we just go to the UCI repository, can you see? I think you cannot see, huh?
No, I can see.
Okay, so maybe you can apply the UCI datasets. You can just open the website.
I can see now.
Okay.
I can
And
see, doctor.
okay, so this is different data sets, a lot of data sets which you can use any data set from this. These are the data set names. Okay, and you can use the classification data sets. You can download any regression data set. You can use any clustering data set. You can use any like something like this. So can you tell what is classification, what is regression, what is clustering? Now I think you have learned.
Yeah. So classification, when we have discrete values.
Okay, like categories.
When we want to, yes, when we want to classify these information. But regression, when we have continuous data, so we have to apply this algorithm. For example, regression, linear regression, logistic regression, like this. Clustering mean grouping the data.
Great. It means that in clustering, you will not have the labeled. Okay. So for example, if we
Yeah.
just want to find some classification data, you can just click here and he will show you all the classification data. Okay. So what you can do, you can just go here. You can say that it has the 5 attributes. What is 5 attributes? It means 5 features or 5 columns. And number of samples or number of examples or number of instances, it has 7,840. Okay. So these are different data sets.
Yeah.
If you want to see this data set, you can just click here and you can see here like number of attributes or number of features are 5, number of instances or number of samples or number of examples are 7,840, and area is computer multivariate and the data is classification data. There is no missing value in the data, so no need pre-processing. Okay. So
Yeah.
if you want to see the data set, you can just go to the data folder. So if you want to just see the relationship like information, you can just go down and you can see that. Yeah. So
Doctor,
these are,
can I ask you something?
yeah.
Doctor, I heard the doctor said fitting. Fitting mean preparing the data, right?
Training the data, not preparing.
What?
Preparing is like you have to remove the missing value, you have to remove the noise, but fitting is not the preparing. Fitting is about training the data.
Yeah, so I confused when the doctor said fitting
Yeah.
is when you want to prepare the data. I
No.
thought it was something wrong.
No, yeah. The fitting is actually it's like you have to fit the data, like you have to fit the model. Okay, fit the model is like you already have a data and you have to fit the model according to the data. Okay, so for example, we can just go back in the maybe, yeah, here. So can you see this lecture?
Linear? Yeah.
Yeah. So here, if you see in the equation where he is fitting something, you can just find an example here. Wait. Yeah, here maybe. Yes. So if you see here, after the pre-processing, he is fitting the transform. Okay, here. Or you can say like this is the fit. Poly regression dot fit. Fit is like you have the input data and you have the output value, and you are trying to find the relationship and you are trying to fitting the data based on the linear regression model. But with the time you will learn. Just forget this.
Okay. Yeah. Okay.
Okay, so these are the different data sets which you can use. I just show you the UCI one. So you can also find the other data sets and you can download any data set and you can then apply different algorithms of that. You can use Kaggle, you can use GitHub datasets, Hugging Face dataset. Maybe you can use the UCI repository. You can use Google dataset, something like this. Okay.
Okay.
And any question?
No, doctor, thank you.
So we can start next. Okay.
Yeah.
Okay, so our next lecture is about linear models for regression. Who is teaching you from these two?
Dr. Saleh,
This one.
the zombie Dr. Saleh.
And how about this?
This one, Dr. Najud, she is not teaching this course this semester.
Okay. Okay, so we can start this.
You know, Dr. Najud is better than Dr. Saleh. She has ability to teach.
Okay, so this is, she is girl and he's boy. Okay, right?
Yeah.
Okay.
Mm.
Okay. So who will be your supervisor?
My supervisor,
Mhm.
Indian doctor.
So Indian doctor. Okay. So you have decided your supervisor?
Actually, we are now in semester 2, but I am here and this is the first year. At the end of this semester, they will give us the name of supervisors, a set of supervisors, and we will choose. But actually, the Indian doctor chose me before. He said, Hiba, I will be your supervisor. I said, okay.
Good. So why he choose you?
Because I used to help him, and also I can make a research. Actually,
Okay.
I did a paper. I did a paper last year, and before 3 months, it is published now.
Okay, your paper is published, really?
Yes, in IEEE.
Great, great,
But
great.
all my papers, I have 3 papers, but they're all survey. I did
Oh,
not do experiment research.
so all survey paper. So can
Yeah.
you send me the link of your paper?
Okay, doctor, don't worry.
Yeah, maybe after that you can send. Okay. So, Hiba, how can
Okay.
I apply in? You are in Saudi Electric University.
What?
You are in Saudi Electric University.
Yeah, not Electric University. I'm in University of Tabuk.
Oh, maybe some of my other student is in that university. Yeah, maybe Hadil. Yeah. Okay, sorry.
Yeah.
I mixed two girls.
There.
Yeah.
Really?
Yeah.
This course?
Yeah. No, that girl is in third semester and it's about thesis. So she is in Saudi Electric University. There is some university with this name. I remember maybe Hadil told me about she is in this university. It's okay. So I
Yeah,
have
yeah.
many students from Saudi Arabia, but
This
most
is
of,
great news, doctor.
yeah, most of them are in third or fourth semester. Like they are learning, they are writing thesis. So
Yeah.
yeah, you are only one who is learning now. You know, the previously I have some Kuwait girl, Abir. She was actually learning, but she is PhD, and now it's like you are learning. But most of the girls they only contact for thesis writing, supervision, something like this. Okay.
Yeah, yeah. Doctor,
So,
maybe I will, if you're good in making thesis, I will make you help me. I can work.
mhm,
Yeah, you will be my supervisor. It's okay.
it's
I
okay.
can ask you
Mhm.
for things, but I can write. Yeah, for example, I can write thesis, I can write research,
That
I
would
can
be good.
also write papers.
Yeah, actually,
Yeah.
the other girls, they have less time, you know, the boys, girls, the so they actually, most of them are like, they are like Saudi boys, mostly they in UK and US. So they are actually doing jobs there, and they only want degree, you know. So I'm writing thesis for them. So
But doctor, I was working in university for 2 years as a
mhm,
teacher,
mhm,
but now I stopped because I'd like to complete. I can't do two things in one time: teach and learn. I can't
mhm,
do this. So
mhm,
I choose to complete master.
mhm,
But the main problem is I can't understand with Dr. Saleh.
mhm,
He can't teach me. I
mhm,
don't know why. I can't understand from him. He has a bad technique in teaching. Not only me, all my friends also having the same problem.
mhm,
Sometimes I used to open YouTube, but I can't also understand because the main idea I did not understand what is the main idea.
mhm.
So I choose Fiverr and I was searching, and I found your page. And I said, "What about trying this doctor? It seems good." And you're also good. Yeah, I did not need to repeat anything. I understand very fast with you, doctor.
That's great. It's a very good
Yeah,
compliment for me. Thank you.
thank you, doctor. Yes.
Okay, so I think we have talked a lot. Let's now we can start. Okay.
Yeah. Okay.
Okay, great. Uh, okay. So now, yeah. So what is regression in machine learning? Uh, this is like we already discussed about this. Like we have, for example, we have classification, categorical data. We will apply classification. Otherwise, we will apply the regression. Okay, like continuous data. So these are different algorithms like linear regression, multivariate linear regression, lasso linear regression, ridge linear regression, normal equation. So we will discuss one by one. Okay?
Okay.
So let's start. So it's just a recap. You can, I think, no need to discuss. We know that we have the training data. We will learn by training some model, and then we will have some test data to check the prediction, like what is the accuracy. So this is like a basic
Yeah.
way. So we know that this is also like supervised learning. We have regression and classification data, and we know regression data is to predict real value, and classification is the discrete value. Okay.
Yeah.
Okay. Supervised learning, we know the most common approach to machine learning is supervised learning. First, we have to collect the data of labor training example. Then we train a model to output accurate prediction. So we have to do training. Then we have to see new data, similar data, it will be the accurate. So it means we have to test it. So we have to collect the data, we have to train the data, then we have to test the data. So these are three most common approach, like the most common approach, and these most common three steps for supervised
Yeah.
learning. Okay. So represent the data. We know that we have to split the data. We have to divide the data set into training and testing. Okay, so use the training examples to construct hypothesis or function approximator. These are just the name of model. You can say we have to train the model. So based on this, we can say
Yeah.
we have to construct the hypothesis or function approximator, anything. So we can say anything. So evaluate hypothesis on test set. So we know that how we can evaluate, how we can test, how we can find the how much accurate is that. So we have to apply it on the test set. So this is the way. Next, split data set into training and testing data set in Python. How we can do that? We know that we will use the sklearn library, which we know that scikit-learn. So this sklearn
Yeah.
library, here is a model selection. So we can import train test split. You can just remember this thing. It's like you can memorize it, and it's you will use a lot in your if you will become a data scientist, in some company or something, you have to apply this like train, test, split. And this will be like X train, X test, Y train, Y test. It's like, you know, like the training data set and the testing data set, something like X test and Y test. So this is like you are going to submit here, and test size you can choose any. If you will make it zero point 0.2, it means 20% you are choosing for testing data set and remaining 80% for training. If this is like 0.33, it means that 33% you are choosing it for testing and 67% for the training. So you can change it anything. Okay. This X is the actual input variables. This Y is the target variable or output variable. You remember?
Yes.
Okay. So this random state is
Doctor,
just,
Doctor, random state, it is the sample from the data set.
yeah. So you can just like put some seed or something. So it's like you
Okay,
can
what
just,
about the size?
size is like I told you, you can split the data into two parts. So this is based on like what will be the size of the test. Okay, so if you will give 0.2, it means 20% testing and 80%
The
training.
rest,
The rest is
training,
training.
yes.
If you like 0.1 mean 10% for testing, 90% for training. So it's like this.
Yeah, okay, I
Easy.
understand.
Right.
Yes, it's easy.
Okay, so this one was your example, like your is assignment. So
Yeah,
I think you know it much better. So we can just go through it quickly. Okay.
yeah, okay.
Yeah.
Partial
So
derivative, yes.
yeah, calculus review, partial derivative. In mathematics, a partial derivative of function of several variables is its derivative with respect to one of those variables with the others held constant. So we have to make all other constant. That's why it's called partial derivative, not full derivative. So partial derivative is like you make all other constant and you only derivate one. Okay, with like one. For example, you can make the derivation with x, you can apply derivation with y, or you can derivative with z. So like for example, this is
Yes.
a example, x raised to the power 4 minus 3x by z. So if we will derivate it with x, so we know that we will make other constant like y and z will be constant. So this one is
Yeah.
simple, like 4 will become in start and x and 4 minus 1 will be 3. So it will become 4
Yes.
x raised to the power 3 minus will remain same and 3x will be 1. Okay, so this will be yz. So minus 3 yz.
Yeah.
And same for the y, because this has no y, so it will be removed. Then minus 3 x z, because y will become 1. Easy.
Yes.
Same
Yes,
that
it's
with the
easy. Yes.
z. So there is no z, so this will be 0. Minus 3xy and z will become 1. So minus 3xy. Done.
Yeah.
Okay, so this
Done. Yes.
other example. So you can see that if we want to make it with x, so it will be like 5 will come here. So 5 into 2, 10. 10x raised to the power 4 plus,
Plus
because there is no x, it will be removed.
15.
No, it will be
Yes,
removed
but
because there is no x. So this will be
okay.
removed. Minus 16.
16 x1.
Yes.
Y2 z2.
And yeah. So x will it will become 1. So of course, like it will be x1. Okay. So 16x y square z square. Okay. How about if we will apply with the y? Like we want to derivate it with the y. So what will be the
The
answer?
first part is 0,
Yeah, 0.
and it will be 15y power 4
Yes.
minus minus 16
Mhm.
x2 16 x2 y1 z2.
Great. Great. Okay, how about Z?
First part is 0, second part is 0. It will be 16 x2, x power 2, y power 2, z1.
Great. So I think
Yeah.
now you know partial derivative.
Yes,
Okay, great. So why we are learning this partial derivative?
I don't know.
Okay, you don't know. Why you don't know? Why Shamani puchta?
Or I don't know why.
What I said,
But
you know?
I only know. Listen, what I
Uh-huh.
know is we do a partial derivative for the hypothesis. But what is the main job of the hypothesis? It helped me to label the data.
Okay.
Right?
Hypothesis is like model. Yeah. So you have to train the model is like hypothesis. Okay. And your hypothesis is true or not. It means that your model is true or not, or your model is correct or not. You will apply the test set on the hypothesis and you can find how good is your hypothesis. So it's like hypothesis is the model, or
Yes.
you can say the algorithm, machine learning algorithm is your hypothesis. Okay. But partial derivative is like you have, it will come like, you know, gradient descent, you have learned gradient descent, and in the gradient descent
Yes.
you have to find the parameter tuning, you have to find the values of the parameters. So what you actually do there, for example, if there are two parameters, so you will make the partial derivative with one parameter like maybe x, then you can find the partial derivative with y, then you can partial with z. So you can find the values of x, y, z to reduce the loss, or to train, or you can improve the accuracy based on this partial derivative. That's why the gradient descent is called optimizer. But just forget it. We, when it will come, you will
Okay.
learn. Okay.
Okay. Yes.
Great. Okay, so calculating gradient with PyTorch. So this is an just like the code of that. So 3x square plus 4x plus 2. So this is the way, and how you can apply with the x, like the curly D notation. You can do the partial derivative with respect to x. So we know that it will be 6x plus 4 plus 0. Okay, and if we will, x will be, it should be like 3, but they put it 4 here. So if it could be 3, then like 16 by 3, 18 plus 4, 22. Okay.
Yes. Yeah. Yeah.
Yeah, then this is this code. They have used the PyTorch library to torch.sensor 3 required grades or whatever. So this is just like 3x here plus 4x plus 2, this one. They have wrote and this print. So this is just the example. Okay.
Yeah.
So the components of a supervised machine learning algorithm. We know that these are very important components. Training example, training example, we know that this is the same which we have already seen. Xi is the input variable, yi is the output variable, our label variable, and these are from I from 1 to n mean the number of examples or number of rows in the data set. So if n
Yes.
is 7, then
Yeah.
for there will be 7. And a model. A model is a function that represents the relationship between x and y. Okay, so we have to find the relationship between the x and y, because x is the input variable or independent variable, y is the output or dependent variable. So we have to find the relationship between independent and the target variable, and then that will be the model.
Yes.
Okay, next one is a loss or a cost or an objective function. So all are the same meaning. You can call it loss function, you can call it cost function, you can call it objective function, which tells us how well our model approximates the training example. Like it will tell us how good a model is. Like mean square error or any objective function you can use, and then you can find that what is the difference between the actual value and the your predicted value. For example, if Your actual value was 20. Like you say that the price of the house, actual price of the house was 2 million, but you have found it like 16, or you can say 3 million. So the difference will be 1 million. So this is like loss of your value. So we will apply some values and then we can say, okay, how we can, what will be the loss of that model? And based on the loss, how you can improve, how you can optimize, this is the optimization function. So optimization is a way of finding the parameter of our model that minimize the loss function. So whatever the loss we have found here, we have to minimize that loss. How we can minimize the loss in the model? We will apply some optimizer.
By using optimization.
Yes, we will use.
Yeah.
So maybe gradient descent or something you use.
Sir, I have a question.
Yeah.
Okay, doctor. The doctor said we should make the loss function equal 0.
Exactly.
The output of the loss function should be 0. Yeah, so the 0 mean if I have the loss function 0, so my value is exactly on the line. For example, linear regression, right?
True. So it means you have to reduce or minimize the loss as much as possible. So if your loss is 0, it means your algorithm is perfectly fine. Okay.
Yeah.
So you have to minimize the loss, but how you can minimize the loss? You have to find the values of the parameters by using some partial derivative or something. So gradient descent can be one optimizer. So you have to do the optimization to minimize the loss function. So your professor said correctly. Okay.
Yeah. Okay.
So next is we have features. Features is like number of input columns. This label is your output column. So input feature, output feature, and you will predict function, like you will train the model with some parameters theta. Then you will have some predicted value. So you have some predicted value. You have to find the loss function or cost function. You have to find what is the loss. So you will find the difference between the label y and the output of the model. So if the loss or cost is 0 between these two, it means your model is perfect. But if the label y is different and label this one is different, so there will be some loss in the data. So how you can minimize the loss? You have to do some optimization. And how you can do the optimization? You have to tune these parameters. And how you can tune these parameters? You have to apply some optimizer. Okay, some gradient descent or something. So in this way you can, when your label and your output label, like predicted label and actual label, it will be 0, like it will be same. So your loss or cost will be 0. Then you can say your prediction function is perfect, or you can say your hypothesis is 100% correct, or you can say your model is very accurate. Okay.
Yeah.
Okay, great. Linear regression. How about tomorrow? This one.
Tomorrow? Yeah, it's okay. Because I've had enough now.
Yeah, it's okay. So from here, we can learn linear regression. 1, 2, 3, 4, 5. Yeah, because this is a full function, you can say. So like full lecture about linear regression and multivariate regression. So this one we can learn tomorrow. Okay.
Okay. Yeah. Okay.
So any question till now?
So doctor, we have linear and linear, multilinear, and also I can see gradient descent, for example, and also polynomial and logistic regression.
Yeah.
Yeah. Okay.
So this one and this one, these two we have to learn, okay? And then logistic regression, the third lecture.
Yes. Okay. Yes. Inshallah.
Okay, great.
Thank you, Doctor, so much.
Welcome. Allah Hafiz.
Yeah. Goodbye.
Goodbye.